The 2005 National Electrical Code, or NEC, is a comprehensive set of standards for safe electrical installations. To better understand and apply the NEC, several handbooks are available. Two prominent handbooks from 2005 are the National Electrical Code Handbook by Charles R. Miller and the 2005 NEC Changes Handbook by Michael Holt Enterprises. The National Electrical Code Handbook by Charles R. Miller is a comprehensive guide to the entire NEC. It provides detailed explanations, examples, and illustrations to clarify the code requirements. It is designed to help electricians, engineers, and inspectors understand the intent and application of the NEC. The 2005 NEC Changes Handbook by Michael Holt Enterprises focuses specifically on the changes made in the 2005 edition of the NEC compared to the previous edition. It highlights the new and revised requirements, explaining the reasons behind the changes and their implications for electrical installations. This handbook is particularly useful for those who are already familiar with the NEC but need to update their knowledge with the latest changes. When using the NEC and related handbooks, it's important to understand some fundamental electrical concepts. Firstly, voltage refers to the electrical potential difference between 2 points, measured in volts. Common voltage levels in residential and commercial buildings include 120 volts, 208 volts, 240 volts, 277 volts, and 480 volts. Secondly, current is the flow of electrical charge measured in amps. The amount of current flowing through a conductor depends on the voltage and the resistance of the circuit. Thirdly, resistance is the opposition to the flow of current measured in ohms. Conductors with low resistance allow current to flow easily, while insulators with high resistance impede current flow. Ohm's law states the relationship between voltage, current, and resistance, expressed as voltage equals current times resistance. This fundamental law is essential for understanding and analyzing electrical circuits. The NEC specifies requirements for conductor sizing to ensure that conductors can safely carry the intended current without overheating. The ampacity of a conductor is the maximum current, in amps, that it can carry continuously under specified conditions of use without exceeding its temperature rating. The NEC provides tables such as NEC Table 310.15b16 that list the ampacities of different types of conductors based on their size, insulation type, and installation method. When selecting conductors, it's crucial to consider the ambient temperature and any directing factors that may apply. The NEC requires that conductors be protected against overcurrent, such as short circuits and overloads, by using fuses or circuit breakers. Overcurrent protection devices are designed to interrupt the flow of current when it exceeds the safe ampacity of the conductor. The size of the overcurrent protection device should be matched to the ampacity of the conductor it protects. The NEC also specifies requirements for grounding and bonding to ensure electrical safety. Grounding provides a low impedance path for fault current to return to the source, allowing the overcurrent protection device to trip and energize the circuit. Bonding connects all metal parts of the electrical system to create an electrically conductive path, minimizing the risk of electric shock. Grounding and bonding are essential for protecting people and equipment from electrical hazards. The NEC addresses various wiring methods, including conduit, cable, and raceway systems. Each wiring method has its own set of requirements for installation and support. Conduit is a rigid or flexible metal or plastic tube used to enclose and protect electrical conductors. Cable is an assembly of two or more conductors insulated from each other and enclosed in a protective sheath. Raceway is a channel designed to hold and protect electrical conductors, cables, and bus bars. The NEC also covers the installation of electrical equipment such as panel boards, transformers, and motors. Panel boards are enclosures containing overcurrent protection devices for branch circuits. Transformers are used to step up or step down voltage levels. Motors convert electrical energy into mechanical energy. The NEC specifies requirements for the location, mounting, and wiring of electrical equipment to ensure safe and reliable operation. The NEC also includes requirements for special occupancies, such as hazardous locations, healthcare facilities, and swimming pools. Hazardous locations are areas where flammable gases, vapors, or dust may be present, creating a risk of explosion or fire. Healthcare facilities have special requirements for electrical systems to ensure patient safety. Swimming pools have requirements for grounding and bonding to prevent electric shock hazards. The NEC is a constantly evolving document, with updates and revisions occurring every 3 years. It's important to stay current with the latest edition of the NEC to ensure that electrical installations comply with the latest safety standards. The National Electrical Code Handbook by Charles R. Miller and the 2005 NEC Changes Handbook by Michael Holt Enterprises are valuable resources for understanding and applying the NEC. These handbooks provide detailed explanations, examples, and illustrations to clarify the code requirements and help ensure safe electrical installations. In addition to these handbooks, there are many other resources available for learning about the NEC, including online courses, seminars, and workshops. By taking advantage of these resources, electricians, engineers, and inspectors can improve their knowledge of the NEC and ensure that they are following the latest safety standards. Electrical safety is of paramount importance, and the NEC is the foundation for safe electrical installations. By understanding and applying the NEC, we can protect people and property from electrical hazards. Remember to always consult the latest edition of the NEC and follow all applicable codes and regulations when working with electrical systems. If you are unsure about any aspect of electrical work, it's always best to consult with a qualified electrician. The NEC covers a wide range of electrical topics, including wiring methods, overcurrent protection, grounding and bonding, and equipment installation. It also addresses specific requirements for different types of occupancies, such as residential, commercial, and industrial buildings. The NEC is organized into chapters, articles, and sections, making it easy to find information on specific topics. The chapters cover general requirements, wiring and protection, wiring methods and materials, equipment for general use, special occupancies, special equipment, and special conditions. The articles provide more detailed information on specific topics within each chapter. The sections provide specific requirements for different aspects of the topic covered in the article. When using the NEC, it's important to understand the definitions of key terms. The NEC includes a glossary of terms that defines many of the terms used throughout the code. Understanding these definitions is essential for interpreting the NEC correctly. The NEC also includes informational notes that provide additional guidance and explanations. These notes are not mandatory requirements, but they can be helpful in understanding the intent of the code. The NEC is a complex document, but it is essential for ensuring electrical safety. By taking the time to learn and understand the NEC, electricians, engineers, and inspectors can help protect people and property from electrical hazards. The National Electrical Code Handbook by Charles R. Miller provides detailed explanations and examples to help clarify the NEC requirements. It also includes illustrations and diagrams to help visualize the concepts. The 2005 NEC Changes Handbook by Michael Holt Enterprises focuses specifically on the changes made in the 2005 edition of the NEC. It explains the reasons behind the changes and their implications for electrical installations. Both of these handbooks are valuable resources for anyone working with electrical systems. In addition to the NEC and related handbooks, there are many other resources available for learning about electrical safety. These resources include online courses, seminars, workshops, and publications. By taking advantage of these resources, electricians, engineers, and inspectors can stay up to date on the latest electrical safety standards and best practices. Electrical safety is a shared responsibility. Everyone who works with electrical systems should be knowledgeable about the NEC and follow all applicable codes and regulations. By working together, we can create a safer electrical environment for everyone. The NEC is not just a set of rules and regulations, it is a guide to safe electrical practices. By following the NEC, we can prevent electrical fires, shocks, and other hazards. The NEC is constantly evolving to address new technologies and challenges in the electrical industry. It is important to stay informed about the latest changes to the NEC to ensure that electrical installations are safe and compliant. The National Electrical Code Handbook by Charles R. Miller and the 2005 NEC Changes Handbook by Michael Holt Enterprises are valuable resources for understanding the NEC and its changes. These handbooks can help electricians, engineers, and inspectors stay up to date on the latest electrical safety standards and best practices. Remember, electrical safety is everyone's responsibility. By following the NEC and working together, we can create a safer electrical environment for all. Always consult the latest edition of the NEC and related handbooks for the most up-to-date information on electrical safety.